Skills practice, page 104, B8. Let's write down this question. I'm just finishing up questions that, for some reason, I didn't go over in class. Let me write down the problem. All right, so I'm going over skills practice, page 104, B8. Here's the problem. I'm going to read the directions. Determine the quotient for each expression. Describe any restrictions for the variables and simplify the answer when possible. So again, you can factor either before you apply the division sign or afterwards. Okay. In the last problem, I factored before, and I'm just going to change it, and it's still the same. You're going to get the same answer, but I'm going to show you guys that they're essentially the same. So if I apply the division symbol now, this will turn into multiplication, and I'll need to flip or take the reciprocal of the second one. So the 2x minus 1 is now on top, and x squared plus 3x is down on the bottom. And then this remains the same. Feel free to say hello in the chat. It is recorded. All right, now we need lots of factoring. Let's factor this one. Our answer we're going to put here. And remember, a value is equal to 1, so on this problem, all I have to do is just the x. All I have to do is just the x. Over here is our side work. So I have a times c. So 1 times 3. My b value I have is 4. And so now I'm going to multiply two numbers to multiply to be 3, but add to be 4. That's going to be 1 and 3. 1 times 3 is 3. 1 plus 3 is 4. So I have x plus 1, x plus 3. We're going to have to factor this one. Now, this one has an a value equal to 2. So that means you're going to have to use both x and the box. This problem, the a value is equal to 1, so you just have to use the x. That's the quote-unquote shortcut. If you're not sure, then you can just use both x and the box. So I have a times c. It's going to be 10. B value is negative 11. Two numbers that multiply by 10 are 10 and 1. And they have to multiply to equal negative 11. Add to be negative 11. They can both be negative. Does that work? Negative 10 times negative 1 is positive 10. And negative 10 times negative 1, negative 10 plus negative 1, or negative 10 minus 1 equals negative 11. So that works. So those two numbers will always go bottom left and top right. The two circled terms are splitting this middle term here. That's why I have to add an x. Right? Negative 10x minus 1x is a negative 11x. Now, in the top left, you will always write this term here. So let's write that, 2x squared. Bottom right, you're always going to write the last term, or the c term, so that's 5. And now we're just going to pull out the greatest common factor. They have an x in common. This one they have a 2x. Okay, this one's a little bit tricky. I'm not sure if it's positive or negative. So for now, you can just write a 5. This one, the only thing they have in common is a 1. And now you can multiply to check your answer. So x times 2x is 2x squared. 1 times x is negative 1x. That means that this one has to be negative. 2x times 5 is 10x, so this one has to be a negative 2. 2x times negative 5 is negative 10x, and negative 5 times negative 1 is positive 5. So in pink, my answer is going to be x minus 5, 2x minus 1, multiplied by... Now, a big idea in simplifying rational expressions is you can put parentheses around these. No, it's not wrong. It's okay. Good thing to do. Remember, it's kind of like they're in a relationship. You can't break them up. They're together. X squared plus 3x. You could make this a trinomial by putting plus 0 and then using your x method. Totally fine. It works. Let me show you that it works. I'm going to put a plus 0 there. So let's just say you don't recognize that this problem has the greatest common factor. A value is equal to 1. A times C is 0. B value is 3. Two numbers that multiply to be 0 but add to be 3 are 0 and 3. So you would have something like this. X plus 0, x plus 3. Now, we normally don't write the 0. So essentially what that is just an x. And if you did the original problem, you realize your GCF is just x. Does that make sense? So two ways to do the blue. Put it here in blue. You could have just x method, or easier, just greatest common factor. Pull out an x. All right. Let's go ahead and do our canceling party. What can we cancel here? One from the top, one from the bottom. X plus 3 divided by x plus 3 equals 1. 2x minus 1 divided by 2x minus 1 equals 1. All right, so in the numerator, I'm just left with x plus 1. And in the denominator, I'm left with these two. Remember, you don't need to write the plus 0, so I'm going to put the x in front. Monomials go in front, and then x minus 5. All right, describe any restrictions for the variables. So now we're going to go back and look at division. So in the last problem, he said define your restrictions, look at the original problem. Now this works for multiplication. Let me write that. But for division, the restrictions are both at the division and multiplication. So let me point that out to you. What does that mean? In this original problem, I don't want to put in a number here to make this equal to 0. Because if I do, anything divided by 0 is undefined, then it can't do the problem. So 2x minus 1 is going to be one of my restrictions. 2x squared minus 11x plus 5 is going to be another restriction. And previously in your packet, if you did multiplication, this would also be another problem. So essentially, division and multiplication are the same problem, but here, there's my restriction, x squared plus 3x. So there you have 3 restrictions. Let's go ahead and complete those restrictions. You just set them not equal to 0. And you already did a lot of hard work above. But let me finish this problem. So I'm going to add 1. Zoom in. 2x is not equal to 1. And then if I divide that by 2, I get x equals not equal to 1/2. So there's one restriction. Okay, this problem here, 2x squared minus 11x plus 5. How do you solve for x? Well, you just factored above, so let's use that information. There's my answer. I'm going to copy that. And then I'm going to set each of those not equal to 0. And you'll notice that the restriction here actually comes out to be the same. And you don't have to write duplicate restrictions. I'm just kind of telling you, like, let's not do more work. Add 5, x is not equal to 5. So there's the second one, and then this last one, we said the easiest way is just to factor out an x. And what you're doing is you're splitting, just like this problem here, 1, 2. You're setting each of those equal to, so I can use a different color pen. You're setting each of those not equal to 0. You're doing the same thing here. So x is not equal to 0. And you don't have to do anything there. So that's an answer. That's a restriction. And then x plus 3 is not equal to 0. Subtract 3. X is not equal to -3. All right, so let's list out all of our restrictions together. X is not equal to. They like to put them in order from least to greatest or negatives to positives. So -3, 0, 1/2, and 5. This is my answer. Try to double box that. So that's our answer for Skills Practice, page 104, B8. I'm going to exit out of this YouTube Live and start a new one to go over question B10. Hope that was helpful. See you soon.